So in DDoS attack, this is application layer attack. Okay, so this is a diagram showing that there is a get method used by the bots in order to target the particular victim machine, and you can see there is an attacker who is trying to control these three bots. Okay, so I think you already know what is a get method and post method and put method, etc. So this particular example shows the get method. Okay, so sometimes referred to as a layer 7 DDoS attack in reference to the OSI model we have, which indicates the application layer. The goal of these attacks is to exhaust the target's resource to create a denial of service. Okay, so it basically targets the application layer. So the attacker will try to use the particular browser or uh, applications like Postman, etc., in order to do a particular HTTP request, right? So everything is happening in the application layer. So what happens is the attacker tries to find certain vulnerability or certain loophole in this particular layer in order to perform the attack. The attackers target the layer where web pages are generated on the server and delivered in response to HTTP requests. So whenever a page is requested from the sender's end, suppose you are using the browser, whenever we type a URL and click enter, so what happens is a request is uh, forwarded to the server end, and the server has to create the particular content to send it back as a response. A single HTTP request is computationally cheap to execute on the client side, but it can be expensive for the target server to respond to, as the server often loads multiple files and runs database queries in order to create a web page. So though it seems very simple that we are requesting a page and the server is responding back with the required page, but sometimes a lot of computation has to be done in the server end to generate that particular page, because that web page may contain various information from the database, and then some query language has to be run in order to fetch the information from the database and put it in the web page, right? So though it may seem to be a single web page, a lot of computation may be requiring in the server end. Now if that particular request is done from multiple users or from multiple requests, then huge computation is required. It is like multiplying the same effort for multiple requests, right? And then it creates a lot of load in the server end. Okay, so and then in the end the server may not be able to respond to future request messages, right? Layer 7 attacks are difficult to defend against, since it can be hard to differentiate malicious traffic from legitimate traffic. So in the server end, what the server sees is a simple request, right? And most of the time it is often assumed that the request is from a genuine user who wants to access the particular site. So in that case, even if an attack takes place, it seems to be very normal request to the server end, isn't it? So it becomes very difficult to identify the difference between an attacker's request and a normal user's request, isn't it? So we cannot deny particular request to a particular user unless we know that it is an attacker. So in the end of the day, we have to finally convince ourselves that yes, this is the request from an attacker, and that becomes very, very difficult. So as we mentioned in the as I mentioned in the previous slide, so these are the various ways we can finally decide whether we should respond to a particular request or not. Okay. So one of the examples of application layer attack is the HTTP flood method. Okay. Flood itself says that a huge amount of HTTP request is going to be sent to the receiver end. So whenever we say application layer attack, we normally tend to specify HTTP flood, but there may be other ways. But this is a small example slide taken in order to explain application layer attack. So HTTP flood attack. So this attack is similar to pressing refresh in a web browser over and over on many different computers at once. Large number of HTTP requests flood the server, resulting in denial of service. So what happens is, suppose we have 10 machines, and in all the 10 machines, we try to send requests from those 10 machines to the server, and we are not doing for once, we are doing for multiple times. Suppose we are continuously clicking the refresh button in order to get back the web page, in order to load the web page, right? And normally it is not done manually. It can be done through a particular script, isn't it? So everything will become automated. So we can use a for loop or while loop, and then it will keep on generating the request and sending to the server. So if it happens for multiple different machines, just imagine the load. Just imagine the load a particular server has to take. This type of attack ranges from simple to complex. Okay, so there may be various ways this can be done. So it may be a simple one. You may sit down at home and try to do a simple attack, right? But if a particular attacker creates a botnet, then of course the magnitude of the flood will be more. Then simpler implementations may access one URL with the same range of attacking IP addresses, referrers, and user agents. Complex versions may use a large number of attacking IP addresses and target random URLs using random referrers and user agents. So this type of attacks can be very simple enough, targeting a single URL, or it may be a very complex one where multiple different URLs are uh, uh, attacked, and multiple as you can see, complex versions may use a large number of attacking IP addresses. So the particular botnet may be huge enough, and then it may be trying to access the various random URLs in the server end. So things become very complicated at that point, right? Because it seems to be very normal to access the various web pages of a website, and then it is very difficult to track a particular attacker.